If this switch 1 goes down, then those bippy-doos are no longer being sent or received by switch 2 on this particular port. Even though this port was in blocking state, it still is able to receive bippy-doos, by the way. It's not able to send or receive frames, but it's still able to receive bippy-doos. If there's a failure over here with the root bridge will no longer be sending bippy-doos every 2 seconds. And so this port right here begins transitioning from blocking to listening. The transition time between blocking and listening is referred to as the max age time or the max age timer. This is a period of 20 seconds. How many bippy-doos would have to be missed for a port to transition from blocking to listening state? That's correct. 10 bippy-doos would have to be missed in order for this port to transition from blocking to listening state. Because the bippy-doos are sent every 2 seconds, 10 bippy-doos are missed. Now this switch 2 knows that switch 1 is down or there's some type of communication problem. And so this port transitions to listening state. What the port is listening for is it's listening for other bippy-doos. It's listening for other bippy-doos to see if there's another root bridge that's been elected. This period of time between listening and learning is another 15 seconds. That 15 seconds is referred to as the forwarding delay, the forward delay. And then there's another 15 seconds here, also referred to as the forward delay, between learning and forwarding. Now, what is the port learning? The port's learning MAC addresses. So there's the listening state where we're listening for bippy-doos from another root bridge. 15 seconds later, that port transitions to learning state where it begins learning MAC addresses. Notice I'm still not forwarding frames out of that port until another 15 seconds goes by. The forward delay time expires, and now that port is in forwarding state. If, however, during either one of these states, if it's determined that there is another root bridge that's been elected and that this particular port would create a redundant topology, this port may transition instead back to blocking state instead of going to forwarding state. Depends once again on the cost of the path. This process is referred to as convergence or spanning tree convergence. This is the key issue with spanning tree, as many network administrators will argue back and forth. Years ago, I saw a very heated debate in one class where an instructor and student almost went to blows over this concept of spanning tree as to whether spanning tree should be on or off in their network. That particular company decided that spanning tree should be off in their company, but the instructor said, hey, well, CISCO says that spanning tree should be on. And they almost went to blows. So spanning tree can be a pretty touchy issue. A lot of different opinions about spanning tree because of this convergence issue. What is the convergence issue? This period of time that takes place while all of these ports are transitioning, this is called convergence. This is a total of 50 seconds that user traffic is actually being disrupted. So you want to keep that in mind when implementing spanning tree in your network. You may decide that spanning tree should not be used in particular situations or particular environments, and then other situations, spanning tree becomes the lesser of two evils. Even though you're down for 50 seconds, the fact is you keep that redundant topology without creating all of those other problems that we talked about before. So those are the things to keep in mind about spanning tree. We implement spanning tree in order to have a loop-free redundant topology by placing one port in blocking. This makes it possible for us to keep the redundant topology without creating some of those redundant topology problems such as broadcast storms, multiple frame copies, and MAC database instability. The things to keep in mind about spanning tree is there's one root bridge per network, one root port per non-root bridge, one designated port per segment. The root bridge sends out what we call bridge protocol data units every 2 seconds. And if those bridge protocol data units are not received, the other non-root bridges know that the root bridge is down. Those non-root bridges then transition their ports from blocking state to listening state to learning state, finally to forwarding state. Spanning tree convergence is reached when all ports have transitioned either to the blocking state or to forwarding state.